Now, this video goes through Pythagorean identities. I strongly recommend that you use your formula sheet. Personally, I only remember sine squared theta plus cos squared theta equals 1, and I derive the others. It's on your formula sheet, so you don't even need to do that. Now, where sine squared theta plus cos squared theta is coming from, it's coming from our unit circle. We derived this way back when we were doing mathematical methods trig functions. So basically knowing that this is your y and this is your x, and sine theta is opposite over hypotenuse, so that becomes y over 1, so that's your y coordinate. Cos theta is your adjacent over hypotenuse, so that's your x over 1, so that's your x coordinate. And using Pythag, because we have a right-angled triangle and our hypotenuse is 1, because we know that sine theta is y and cos theta is x, then we know that x squared plus y squared has to equal 1 due to Pythag, so therefore sine squared theta plus cos squared theta has to equal 1. Now, to get our other formulas, if we start by dividing everything by sine squared theta, sine squared theta divided by sine squared theta is 1. Cos squared theta divided by sine squared theta is cot squared theta. And 1 divided by sine squared theta is cosec squared theta. So there's the other identity, which you'll find on your formula sheet. If instead we divided everything by cos squared theta, sine squared theta divided by cos squared theta is tan squared theta. Cos squared theta divided by cos squared theta is 1. 1 divided by cos squared theta is sec squared theta, and that's your other identity. Again, that is on your formula sheet, so make sure you know where that is. So at the top of this, I've put what those formulas are straight from your formula sheet. Now, they are called identities because they are true for every value of theta, or in this case, if we're looking at our formula sheet, every value of A in the implied domain. Calculate the value of sine theta for pi on 2 is less than or equal to theta, which is less than or equal to pi, if cos theta is negative 7 over 25. Now, first of all, the domain tells us we're in our second quadrant, so that means our sine theta is going to be positive when we work out our answer. So write out our identity. Sine squared theta plus cos squared theta equals 1. Plug in our value for cos, so plus negative 7 over 25 or squared equals 1. So sine squared theta plus 49 over 625 has to equal 1. We minus 49 over 625 from both sides. So sine squared theta is equal to 576 all over 625. So that means our sine theta is going to be plus or minus the square root of 576 over 625, which is plus or minus 24 over 25. But pi on 2 is less than or equal to theta, which is less than or equal to pi. We're in our second quadrant. Sine theta is positive. So therefore, sine theta equals 24 over 25. Make sure you put your understanding of why sine theta is positive and not negative as well. Now the second one, if cosec x equals 7 over 4, find cos of x. So if cosec x equals 7 over 4, that means sine x has to be 4 over 7. Our identity, sine squared x plus cos squared x equals 1. Plugging in our value of sine. (16 over 49 plus cos squared x has to equal 1, minus 16 over 49 from both sides. So we have cos squared x has to be 33 over 49. Cos x is going to be plus or minus the square root of 33 over 49. So cos x equals plus or minus the square root of 33 over 7. Now there's no domain given, so therefore it could be positive or negative. Let's look at a couple more. Simplify cos squared a tan squared a. Well, we know that tan squared a is equal to sine squared a over cos squared a. So that means cos squared a tan squared a is going to be cos squared a times sine squared a over cos squared a. Our cos squared a will cancel, so we're left with sine squared a. Next one, simplify cos squared a plus sine squared a plus cot squared, 1 over cot squared a. Firstly, 1 over cot squared a equals tan squared a, which equals sine squared a over cos squared a. We also know that sine squared a plus cos squared a equals 1. Therefore, our cos squared a plus sine squared a plus 1 over cot squared a is going to equal 1 for cos squared a plus sine squared a, and then plus our 1 over cot squared a is tan squared a. Now that's an identity. 1 plus tan squared a equals sec squared a. So you need to be able to recognize those identities. So that's sec squared a. Okay, solve 2 sine squared a equals sine a for 0 is less than or equal to a, which is less than or equal to 2 pi. So get everything on one side. You've got 2 sine squared a minus sine a equals 0. So that means sine a all outside of 2 sine a minus 1 has to equal 0. So sine a has to equal 0, or 2 sine a minus 1 has to equal 0. 2 sine a equals 1, sine a equals a half. If sine a equals 0, my a, remembering that sine is my y coordinate, so that's going to be at 0, pi, and 2 pi. Okay, remembering that sine a is y. For sine a equals a half, our reference angle is going to be pi on 6. Sine a is positive, so we know we're in our first and second quadrants. So a is going to be pi on 6, and in our second quadrant, pi minus pi on 6. So that's pi on 6 and 5 pi on 6. So therefore, a equals 0, pi on 6, 5 pi on 6, pi, and 2 pi. Next one, solve 2 sine squared a equals cos a plus 1 for 0 is less than or equal to a, which is less than or equal to 2 pi. Sine squared a plus cos squared a equals 1, which means that sine squared a equals 1 minus cos squared a. Now, my goal is, because I've got sines and cos in the equation, I'm going to get it all in the terms of cos. So 2 sine squared a equals cos a plus 1. So I'm going to get it all in terms of cos. I'm going to replace that sine, the sine squared a. So it's 2 bracket 1 minus cos squared A equals cos A plus 1. So 2 minus 2 cos squared A equals cos A plus 1. We always want our squared value to be positive, so I can take everything over to the right. So 2 cos squared A plus cos A minus 1 equals 0. Now, you could factorize that with coses, or if it makes it easier, you could say let A equal cos A and get rid of it. So you have 2A squared plus A minus 1 equals 0. And factorizing that, that's 2A minus 1, A plus 1. And that's just from using a factorization method. I've used the cross method, so 2A squared, negative 1, and A. You have 2A and A on this side. Factors of negative 1 are 1 and 1. And because we have negative 1, 1 has to be negative. So that would be negative A plus 2A, which gives us our positive A. So therefore, 2A minus 1 equals 0, 2A equals 1, A equals a half, or A plus 1 equals 0, A equals negative 1, coming back to A equaling cos A. So we've got cos A equals a half, cos A equals negative 1. Now, cos is our x value, so A for equaling negative 1 would have to be pi. For cos A equals a half, our reference angle is equal to pi on 3. Cos is positive, so we're in our first and fourth quadrants. So that means my A is pi on 3 and 2 pi minus pi on 3, which is pi on 3 and 5 pi on 3. So therefore, my A is equal to pi on 3, pi, and 5 pi on 3.